All right, let's just jump right in. Welcome to The Explainer. Today, we're tackling a massive, honestly game-changing topic, data. Our main goal here is to completely demystify how abstract, raw numbers and characters actually get transformed into meaningful, real-world decisions. It's a pretty fascinating journey from raw input all the way to refined understanding. To get us in the right headspace, check out this fantastic quote by Gary Schubert. He says, "Data is not information. Information is not knowledge. Knowledge is not understanding. Understanding is not wisdom." I love this as our philosophical hook because it reminds us that raw data is, well, kind of useless on its own. Just having a massive spreadsheet of numbers doesn't magically give you wisdom, right? That data has to go through a rigorous refining process to actually become valuable to us. So here's our roadmap for today. We are going to look at the power of data, structured versus unstructured formats, the data processing cycle, finding central tendency, and finally, measuring variability. Let's get to it. Section 1. The power of data, making real-world decisions. We encounter data every single day, often without even realizing it's pulling the strings. Data literally drives our choices. Think about dynamic cab pricing, right? Whether it's an airline tweaking its fares or a rideshare app suddenly doubling your costs during a rainstorm, data is the hidden engine making that happen. Or think about a student picking a college. You don't just blindly guess. You look at the placement stats from past years, faculty experience, fees, hostel facilities. Even meteorologists are constantly monitoring satellite data to predict upcoming cyclones. Data is just everywhere. Section 2. Structured versus unstructured data, organizing the chaos. So what does this data actually look like out in the wild? Well, it basically falls into two main camps. On one side, we've got structured data. This is highly organized. It sits in well-defined formats with neat little rows and columns, like what you'd see in a spreadsheet or a database. Think of a store's inventory table. You've got columns for model numbers, prices, stock levels, very clean. On the flip side, we have unstructured data. This has absolutely zero fixed pattern. It's totally freeform. Think about a daily newspaper, an email packed with different attachments and paragraphs, or a social media post mashing together images and emojis. It's basically the messy, unstructured reality of how we humans actually communicate. Section 3. The data processing cycle, from raw to refined. Now, this cycle right here is the mechanical heart of our explainer. This is how we take those raw materials and actually make them useful. Step 1 is input, just gathering the raw numbers or text. Step 2 is processing. This is where the system gets to work, sorting, classifying, or updating everything. And step 3 is output, giving us that refined information as clean tables or actionable results. Think of a super everyday example, an ATM. You input your PIN and punch in a withdrawal amount. The system processes that by checking your balance and updating your account. And the output? It spits out your cash and a printed receipt. Simple, right? Booking a train ticket actually nails this concept perfectly. To solve the problem of getting from point A to point B, your input involves typing in stations, travel dates, and passenger details. Then, the processing phase takes over behind the scenes. It verifies your login, checks if there's berth availability, processes your payment, and deducts the ticket from the system. Finally, the output is generated for you, a clear, simple ticket showing your PNR and confirmed berth number. It's literally the perfect encapsulation of that input-process-output cycle. Section 4, Finding Central Tendency, Making Sense of Numbers. All right, this is where we bring in statistical techniques. These are our ultimate tools for summarizing massive amounts of processed data. Let's kick things off with the most common one, the mean. It's simply the average of your numeric values. You just calculate it by taking the sum of everything and dividing it by the total count. But hey, quick warning here. The mean can be super easily skewed by extreme outlier values. If just one number in your dataset is crazy high or crazy low compared to the rest, it'll totally drag your whole average off center. Let's look at an actual calculation to see this in action. Imagine a sample group of 9 students, and we measure their heights in centimeters. We add all those heights up, divide by 9, and boom, that gives us a mean height of 101.33 centimeters for this specific group. But what happens if we do have outliers, like one really, really tall student? That is exactly where our next tool comes to the rescue, the median. The median is the exact middle value when you sort all your given data points in ascending or descending order. It's the central value that perfectly chops the dataset in half. It is a fantastic, much safer alternative to the mean when outliers are crashing the party. Think of it like the safe middle child. One extreme number way up at the top won't shift this center point at all. So, back to our group of 9 students. If we literally line them all up by height, from shortest to tallest, and find the person standing smack dab in the middle, that's the fifth student in line, their height is 102 centimeters. So you can see how the median height in our sorted group is 102, which is close to, but slightly different from that mean we calculated earlier. Moving on to our third tool for central tendency, the mode. The mode is simply the specific value that appears the most number of times in a given data set. Its whole job is basically to win a popularity contest. It finds the most frequently occurring variable in the room. And remember, if no value repeats at all, then you just don't have a mode. Checking back in with our group of 9 students, we find that 110 centimeters is the mode. Why? Well, because exactly 3 students happen to share this identical height, making it the highest frequency in our little group. And just like that, we've successfully found all 3 central tendencies for our students. Section 5, Measuring Variability, Understanding the Spread. Okay, so sometimes just knowing the center point of our data isn't quite enough. We also need to measure how spread out those data points are from one another. The most straightforward way to do this is with a range. Range is just the simple difference between the absolute maximum and minimum values in your numerical data. It basically shows us the total coverage, and you find it just by subtracting the smallest number from the largest. Let's do the math in real time. In our group of 9, our absolute tallest student stands at 115 centimeters. The shortest is 85 centimeters. We take 115, subtract 85, and that gives us a spread, or a range, of exactly 30 centimeters. Easy enough? And finally, the big one, standard deviation. Now, looking at this definition, the positive square root of the average of squared differences from the mean, okay, yeah, it sounds a little intimidating, but let's completely demystify it. Its true purpose is just to show exactly how much individual values spread away from the group's average. That's it. A smaller standard deviation means your data points are all tightly clustered together around that mean. A larger value means they're widely spread out. It is absolutely brilliant for measuring the diversity within a set of data. So, we've gone from defining raw data all the way to advanced statistical measures today. And I want to leave you with this provocative thought. Digital interactions generate massive, just huge volumes of data constantly. So, how much of your daily life is currently being processed as data? Think about it. Every website you visit, every ticket you book, every single purchase you make. I really encourage you to look at your own digital footprint through the lens of everything we unpacked today. Remember, the raw data is out there, but it's the careful processing and analysis that transforms it into true understanding. Thanks so much for learning with me today, and I'll catch you on the next explainer.